just for posterity. Okay, so let me talk about the syllabus for Economics 403, Spring 2021. I've already started to tell you a little bit about this, that you're learning tools and methods that will be not just for this class, but for other classes that you take, specifically your upper level undergraduate economics courses. If you take econometrics, or I think Leslie Stratton teaches a course with labor economics, or there's macro and micro that this will help to prepare you for, but there's a few other ones too. It's an introduction to more advanced math techniques. What are those techniques? Of course, calculus and how to optimize a function. That's a lot of what economics is. Here's a function, optimize it, maximize it or minimize it. I want to talk about matrices because you don't have to use matrices in everything going forward, but it's nice to have it as an option. Is to take some equations and think of them as a matrix rather than a system of equations. If you can do that, I think it'll help you. There's different types of calculus when you start to talk about multivariate calculus. We'll do that. And of course, optimization problems with or without constraints. I would say that's the biggest thing. The biggest thing I have to teach you and that you have to learn in this semester is probably how to solve constrained optimization problems. It's a problem where the simplest one I can think of is maximizing utility given a budget constraint. So some of you have already done that before. You probably think that's easy. I don't need a whole semester worth of math just to teach me how to maximize utility given a budget constraint. I already know the answer. It's where the marginal rate of substitution equals the slope of the budget line. You're right, it is. It is where the marginal rate of substitution between the two goods is equal to the slope of the budget line. What if you have more than two goods? Aha. What if there's three goods and you have to maximize utility for three goods or four or n? What if there's not just one constraint, one budget line, but there's another constraint? There could be a budget constraint, there could be an environmental constraint, there could be a capacity constraint. I guess what I'm telling you is I would like you to know this on a more fundamental level, right? Rather than, I know what the answer is, let me just skip to the answer. The answer is, so let's talk about utility maximization. The answer is, I will choose the point on the budget line such that the slope of the indifference curve is tangent to that budget line. And I have to find that point by using the fact that the marginal rate of substitution is equal to the slope right at that point. That's a great thing for you to know, and just for you to think about this theory of consumer optimization. But it's not general enough. It's not a general enough way for you as a student of economics to think about what's really going on during the consumer optimization process. So as a preview of what we'll be doing well into the future of this class, I would like you to be able to solve almost any type of constrained optimization problem. If you can do that, wow, there's a lot more things you can attack in economics. So that's what I'm trying to get you to be able to do. Okay, special circumstances for 2021. Every meeting will be on Zoom. I might ask you guys what you think about having some reading days where non-synchronous, asynchronous days where I might just post some videos for you to watch and we don't have to meet those days. I've done that in previous classes, and I can just post on Blackboard links to the videos for you to watch. And I might do that some of the time, but except for those times, and I'll let you know in advance when an asynchronous day, I don't want you to think of it like, oh, no school, no class. It's like a snow day, we can do whatever we want. I'd rather you not think of it that way. I'd rather you think of it as, here's an asynchronous day. I can watch the videos whenever I feel like maybe there's a homework attached to it. I think for me, that's good, where I'm trying to get you to do both, watch the video, do some homework problems, ask me about it if you have any problem, if you're confused. But I'll let you know in advance when those days are coming. I haven't decided yet. So for now, please think of Tuesday, Thursday, 12:30 as our regular meeting time. Always at this Zoom link. Oh, textbooks. I recommend one of two textbooks, and one of the splits is so the first one on my syllabus is by two economists, Sid Sater and Hammond, and I would say that is more of just an undergraduate level math econ book. If you know you're only going to get a undergraduate econ degree and stop there, you're not interested in getting a master's or beyond, I would say that's probably the book to get. And I will often use examples from that book. I won't assign homework that says like, do chapter 6, problem 4. And then the only way you can know what it is if you own that book. That's why I decided not to make it required. But it is recommended. You get one of these two books. If you don't get that one, then the other, and I don't have that one with me, but this is the other one. This is more for graduate or upper level undergraduate to master's level textbook. It's by Alpha Chang and Kevin Wainwright, and it's called Fundamental Methods of Math Econ. That would be a good one to have in the long run if you think maybe I'll not just stop here, but keep going in my economics education. Okay, those are the textbooks. How will I do grades? I'm just gonna make it simple. You know, quiz, homework, midterm, final. That's it. I've had people tell me, and especially because in the era of Zoom, people just check out sometimes, and I don't want that. And I probably should have I could have forced you to participate by making it part of your grade. I just felt like for a math course that might anger people a little bit. Like, this is a math course. If you know how to do it, why should you be penalized because you don't feel like participating? So I decided not to. I hope that you will participate and interact, but I decided not to make it part of your grade. So your grade will be these quizzes. There'll be 5 quizzes, approximately 1 every 2 weeks. And we'll do those during class. Over Zoom. I'm not over Zoom, over Blackboard. So what will I do? I will write a quiz and I will make it available during class. And you'll have something like 30 minutes to do it. So I do want them to be timed. But of course it's open book, open note, open computer. It'd be very hard for me to try to enforce some rule that says you're not even allowed to look at any other website on your computer or anything like that. What I will insist though is that you do not use each other, do not communicate with each other about how to do these quizzes. You are expected to work on the quiz or the exam on your own. I might say it's okay to ask for help with homework, to do the homework together, but I don't want you to just copy other people's homework answers. And you have to each person has to turn in their own homework. But I'm okay if you work together on the homework. You see the difference. The homework is meant to be, maybe it's a little challenging. You're like, I can't figure out exactly how to do this. You work with another person, that's fine. You can work with me. You know, you can meet me in office hours. I don't have formal office hours, but just send me an email and I'll have to meet over Zoom. It's the best I can do. But that's okay for homework sets. So work with other people. But for everything else, quizzes, midterm, final, it's got to be on your own. That's the thing I will insist on. Even though it's open book, open note. You don't have to memorize formulas for this class or anything like that. Okay. I'll drop the lowest quiz. Sometimes people have to miss a quiz for some reason, or they have one quiz where they do really poorly. So I'll take the best 4 out of 5 quizzes. I think, why do I say this? 6 homework sets, that's what I had last time. So I think there will be approximately 6 homework sets spread out over the course. 3 before the midterm, 3 after. Okay. And here are the dates that I set for the midterm. March 18th. That seemed like about the middle of class. And then the final is May 11th. I may or may not make those take home. I think I'll see how the quizzes go in terms of time. I'll see how you guys feel about taking a timed exam versus a take-home exam. I'm pretty flexible about that. But if they are a take-home, then I'll say these are when they're due, right? If it's a take-home exam, I'll give it to you before. I'll still make the due time the same. So the only difference between a take-home exam and an in-class exam is how long you have to work on it. That's really the only difference.
Do we have weekly homework?
It's really only about once every other week. So if you want more, I will say this: I will post it so that it will be open. It'll be available to you to work on every week. I'd like to do it, well in advance. Have them posted. I guess you're saying, could you have some more homework feedback? Is that what you're saying? Who said?
Yeah.
Who am I talking to? Kai?
Yeah.
Am I saying that right?
Yes.
Why don't you maybe get the feedback from me individually rather than saying everybody in the class should have more homework sets due more often? I think
Yeah,
that
no, I was just like, yeah, I was just curious, like, how often we had homework due.
it's approximately once every other week.
Okay, that's
But
good.
that doesn't mean that like a week will go by where you have nothing to work on, because you could always be working on, what I'm saying, throughout
Yeah.
those 2 weeks you could be working on the homework set that's due uh, whenever. And if for some reason you're like, I've done all my homework, and I still want more practice problems, then come to me and we'll sort of, if you have the book, I can try to refer some problems to you from the book, or even that's not enough.
And I'm also looking, there's like a fourth and fifth edition. Does it matter which one?
No. Which
They're
one are you
like the
talking
same,
about?
basically.
The Sid Seder or the Chang and Wainwright?
The first one, the
Okay.
essential mathematics, I
Okay.
think.
Yeah. I have a pretty old version of that. It's probably the one I have is not the newest. So I mean, I could get the newest one if you want, but I really don't think it's that different or that necessary.
Yeah, I was just looking because there's a big price difference and it basically looks the same.
Yeah.
But
I would save the money and get the older one.
okay.
What I will do is refer to examples in the book, and I'll even say this. I got this from chapter 3 of Sid Seder, and if you have it, you can go back and look at it. That's one reason it's good to have the book. It's more references for you. But if you don't have the book, you can still follow my reference because it'll be there. Let's say on my lecture notes or something. And even if you don't have the exact same edition as what I say, like I said, it was in chapter 4, but it's actually in chapter 5, or they took it out of the new version for some reason. I don't think they'll do that, but if they did, um, you'll still have similar type problems, I'm sure, in the book than the ones I put on my slides. Okay.
Yeah, sounds good.
Okay. Yeah. Good questions. But that's how your grades will be set up. Just quiz, homework, midterm, final. The exams are worth more than the others too, but they're all roughly equal, either 20 or 30% of the grade. Um, I tried to be pretty specific with the course timeline, even though it is subject to change, of course, by class announcement and email. I tried to do, first quiz week 2, then week 4. Then, by the way, we have this reading day. We don't get spring break this semester, but we do get a reading day, one day uh, on February 23rd that we don't have class. So then week 7 could be our third quiz. Week 8 could be our midterm. Week 11 could be our fourth quiz, and week 13 could be our fifth. And then review for final. Yeah. Um, that's what I was hoping to split up the class into. And so you can see the timeline on the syllabus. It's the best I could do. Um, I've never fully taught this course online. I will say that. I was teaching last year when the pandemic hit. And so I actually had to switch this course from being in person to being online in the middle of it last year. So this year, I know it's going to be fully online. Um, and so that it has some challenges to it. One challenge for me is I like using whiteboards. I like writing like, equations on a whiteboard, and I have to have something which is a substitute for that for this class. And I know Zoom has a whiteboard, but it's not great. I'm sorry. Yeah, I think it's called a whiteboard. Um, sometimes I really think the best solution is the simplest, which is for me to write using paper and pencil and show it to you with my camera. it's very it's very low budget, low tech way, but when you're writing math and there's equations, there's subscripts, there's exactly what does the specific um, character or what's it called a binary operation. I'd like for you to see how I write it, and part of that is you as a student will start to develop some of your own way of writing, and it's influenced by me. I've noticed this. I think it's weird that if I just write something a certain way, you'll all start writing it that way too, and it's natural because you're learning it from me. But I will do that later. I will do some paper and pencil, I think. Okay, I think I went through the syllabus. You guys have any other questions about the syllabus? It's already 107. So it seems like most of you have had some calculus, and that's good. Do you guys have any questions about my name? It's John Lytle, Dr. John.
Have you taught this course in the past?
I've taught the course in the past, yeah.
Okay. Is there anything that you've noticed that people like really struggle with in particular?
Sure. It really depends on the person, but like for example, I have some people who are really good students and they'll listen to everything I say and feel like they're fully prepared. But then if something happens on an exam that's different, they struggle with it. In other words, there's a certain amount of math creativity that it's hard for me to teach you.
Yeah.
It's hard for me to get you to say like, oh, well, you're looking at this function, f of x equals 1 over x, and if you just flip it, think of it this way, it's just like this one we've already done. It requires a little bit of creativity. So there are some students who, and I feel really bad for them because I can tell they're trying, they're giving a lot of effort, and still sometimes, like for a constrained optimization problem, I can sort of tell you what to do, but specifically it depends on the problem.
Yeah.
The way to analyze each line of each equation, I can't tell you everything about that. I can give you like rules and guidelines and principles, and then you sort of have to apply them yourself. So there's certain types of students who struggle with that. But of course, there's other students who struggle for the opposite reason. They might be pretty good at math, but don't really pay attention in class and miss out on some sort of key things that make it hard for them to do well in this class. Yeah, so I think that's it. I think maybe the optimization problems are probably the hardest. The constrained optimization problems, multivariate stuff, multivariate calculus is probably, for some people, the hardest.
Gotcha.
Some people are just not good at algebra, and I feel so bad about them. Like And it's not that they're not smart or don't understand it. It's that they're just not careful. You know what I mean? Like they'll take x plus 1 squared and turn it into x squared plus 1 squared. And they sort of know, if I ask them the rule, okay, what's the rule for expanding a binomial into a squared? They would remember like, oh yeah, it's x squared plus 2x plus 1, if I asked them that. But during this course of solving this particular problem, they weren't even thinking about it. They weren't, what I would say, they weren't being careful. And so many times in this class, it's something simple and easy that causes people a problem. Like they might get the big picture and then make some mistake on something like that, a simple algebra mistake. And I feel like I'm a generous grader. I'll still give you as much partial credit as I think is fair. I won't give you like a whole, almost everything partial credit compared to somebody who just nailed it and got everything right. Because I also think that's not fair when you're talking about, you know, anyways. But I'll be as generous as I can. I'll try to grade you for both your understanding of what's going on and your execution of what was asked of you to solve this problem.
All right.
So that's all I can think of right now.
Yeah. Thank you.
Sure. Just be careful. You know what I mean? when you're simplifying a line of algebra to the next line to the next line, you might think it only takes you 2 seconds of thought to go, but maybe that third or fourth second, which is really just like, oh, wait a second, I got to be careful, might be worth it in this class. Okay, good question. I do have, let's see, I'm screen sharing, but the thing I'm sharing might change, right? Let's go to, we have some time here. I know it's the first day. Sometimes people don't really cover much the first day, but this, I think in this class, it's worth it to talk a little bit about some of the math the first day. Give you some idea of just bigger picture stuff, I think, about the math and the modeling. The first section I want to talk about in this class is actually, what does economic modeling even mean? And what do I mean when I say you solve a model? Do you guys have any thoughts about that? what do you think it means to, quote, solve a model? It might mean something different than what I think. Any ideas? What does it mean to solve a model? This is a mathematical model now we're talking about.
When you're saying solving a model, you're talking about like creating a model, kind of?
No, I'm talking about somebody gives you a model and says, will you solve this model for me?
Oh, okay.
What are they asking you to do?
I'm not sure.
Yeah, you know, this is in my opinion, right? Language sometimes is ambiguous. And the job of a mathematician often is to formalize that ambiguity. Humans speak in words and words are ambiguous. What exactly do you mean by that? The job of a modeler, somebody who does economic modeling, is to say, let's remove all of that ambiguity. We are going to define variables for everything we speak about that we care about. Let's define a variable. You know what a variable is, right? It's often, you know, it's used letters to refer to variables like X, Y, Z. We might also use letters to refer to constants, though. Why would we do that? Why don't we just use the number? We sometimes use a letter to refer to a constant. Sometimes we use a letter to refer to a variable. Why do we do that? Any ideas? And there's this in-between thing that I will call a parameter. So you got variables, parameters, and constants, all of which can be represented by letters. I will say this, usually parameters are Greek, at least in the work that I do, and maybe what I'll try to teach you a little bit in this class is that if you see a Greek letter, often that's a parameter, alpha, beta, theta, lambda, something like that. So a model is really about relationships between values and variables, and you're defining them somehow. You're taking something that's informal and you're making it formal by defining them using math and using equations. So to me, that's what I mean by modeling. Modeling is writing down a series of equations that describe the relationships of some variables that you care about, and it could be involved. It could involve parameters too. It could involve constants too, but mostly it's about the variables that you care about. So I have some slides. I can show you the slides, but really it's just me talking about what I just said. Here we go. You want me to make it full screen? Doesn't matter, does it? Okay, now it's full screen. Sure. So I define an economic model here as a simplified analytical framework for real world phenomena. Of course, we want to use real world phenomena if we're going to be economists. The one everybody here probably knows about is a market. A market is a real world phenomena, isn't it? Markets exist all the time, whether you realize them or not, that people could buy or sell a particular thing if they want to. Like a cell phone, right? This was purchased by my wife for me as a birthday present in a market, meaning that the manufacturer, Apple, I think it's a 12, iPhone 12, so fancy, right? It has these 3 circles here. I wouldn't have selected this, but as a gift, she gave me an iPhone 12 for my birthday. It existed as part of a market where there's people who demand it, who want it. I'm a person who has some demand for that product. Apple is a company who supplies it. They say, we'll produce these iPhone 12s and we'll sell them to people. Well, what's the price? How does price get determined? There are these market forces that determine price. Apple knows I could sell, I can produce a certain amount of these, and the higher the price I can, the better for them, because they care about, they want to have as high price as possible to make as much money as possible. Where there are consumers like me and really my wife who bought it, who want the price to be as low as possible, because you want to save money. And there are substitutes for the product. We didn't have to buy an iPhone 12. I'm sure there's Samsung and other alternatives. And okay, what's my point? An economic model is a way to formalize everything that sort of went on in this transaction into concepts that we are familiar with, like a demand curve or supply curve, and relationships between these quantities. You might say quantity demanded is a variable that we care about. Quantity supplied is a variable we care about. Price is a variable that we care about. And the economic model puts them all together using equations to say, here are the relevant relationships between these variables. If you're familiar with the law of demand, it says demand curves are downward sloping. The law of supply says supply curves are upward sloping. Equilibrium analysis of a market says the equilibrium price will be where quantity supplied equals quantity demanded. That's my review of Econ 101, whatever, I don't know what it is here, 203, 202, the micro course. But now I want you to rethink of that, what you've already learned about that, as a model. And the reason it's a model is because it involves some variables, some constants. The constant could be like the slope of the demand curve or the intercept of the demand curve. It could involve some parameters and exogenous variables and functions. Okay, I have to define for you what an exogenous variable is, or a function. I think you know what a function is, but does somebody already want to say what's the difference between exogenous and endogenous variables?
Is exogenous like
Who's talking?
Tommy. This is Tommy.
Here you go. Oh yeah.
Exogenous is like it's like an outward effect on the variable, or it's not. It's
An outward effect on the variable. What does that mean? Out from what?
well, it's not like endogenous, which is I don't know.
In. You're about to say in, weren't you?
In, yes.
Yeah, that's right. Exogenous is outside the model. Endogenous is inside the model. So that part you got right. To articulate it even better, I would say this. The exogenous variable is not controlled by any agent or decision-making body inside the model. It's only determined by agents or factors or considerations that happen outside the model. That's the big difference. Endogenous variable. In fact, you see my slides here? The second bullet point, I just wrote the word variables. By that, I meant endogenous variables, right? Those are the things you care about. The things you care about are the endogenous variables in the model because they're the things inside the model that will be determined by the model. The exogenous variables, if there are any, are things that are not determined by the model. You can almost think of them as being constant. Because even though the word variable implies that they vary, any variation that happens is happening outside the model and we just don't care about it. So that's what I mean. Right. Any questions about that? I think we got that. Oh, why did I put this thing here about algebraic geometry? I think this is something that will help us in the class. Not that it's part of economic modeling, but that one thing I'd like you to do is be familiar with the shapes of functions. By that I mean a linear, a quadratic, a hyperbolic. Hyperbolic is like 1 over x, would be an example, or a over x. Exponential and logarithmic functions. Why should I care about the shape of a function? It may be because when you use language, sometimes you talk about something going up or something going down, or you talk about the maximum or the minimum or the intersection. A lot of these are visual words, right? You're almost thinking of the intersection of the supply curve and the demand curve is something that, what does it mean to intersect? Okay, it has a logical meaning, but also has a visual meaning. And it would just be so much helpful to learn the shapes of these functions so that, and what happens when they shift around a little bit to get a better idea of what it means to solve a model when they intersect, something like that. When we talk about the slopes of functions, the slope of a function is going to be something that turns out to be very important. And if you know that a quadratic function, for example, it either opens up or it opens down. So if a quadratic function opens up, it has a negative slope until it gets to the bottom, and it has a positive slope going up. Why would that be useful? Because you can quickly identify the minimum point of a quadratic function that is positive. At least the leading coefficient is positive, because if you're familiar with the shape, you immediately get this idea that, oh yeah, the minimum is that point right at the bottom where the slope is 0. Okay, we'll tell you more about that as we need it. Okay, so 126. Just a quick thing about equilibrium analysis of a model. Usually when you hear that, when they talk about that, finding an equilibrium, it's really a solution to a system of equations. So one equation tells you about the relationships between variables, but you probably need more than one equation to find a solution. The easy way to think of that is just knowing a demand curve isn't enough to tell you what price is going to be or what quantity is going to be, right? That's just one relationship between price and quantity, a demand curve. In order to find price, you need two relationships. You also need the supply curve, which is a relationship between price and quantity supplied. And so in equilibrium analysis of a model, not just a market, but any model, is generally the solution to a system of equations. So I'll give you some examples of this, like what's a model, what are these equations, and what does it mean to solve them? What does it mean to solve a model? Here's my answer, that I asked at the very beginning of this lecture. It is to solve the system of equations that are represented in the model in a way, I'm not done yet, in a way that every endogenous variable can be defined in terms of the exogenous values, meaning the exogenous variables, parameters, constants, or just numbers, you know, like the number 1. If you can do that, if you can define each endogenous variable as something, as some function of everything else, but not endogenous variables. You get what I'm saying? If X and Y are both endogenous, and I say, okay, solve this model, and you say, okay, X equals 3Y plus 1. I will say that's wrong. You haven't solved it. You told me a relationship between X and Y. Good for you. That's good. But you haven't solved it unless you can tell me what X is equal to using only terms that are not endogenous to the model. Okay, that's my answer to the question I posed 15 minutes ago. Any questions about that? Let's see what I have on the next one. I have an example here. You guys want to just try this? I gave you something that's not obvious here because it doesn't have a linear demand curve. It actually has a quadratic demand curve. It has a linear supply curve. I'm asking you now, what is equilibrium price and quantity? Oops, I gave you the answer too. I think I meant to use animations to only show you the first 3 bullets, but I showed you the answer too. So if you don't actually do it, that's okay. But you know, how would you do this? I'm sorry, I don't have anything quite ready. I have some points to bring up here. Or if you see, I see some people are working on it now, and that's good. I'm kind of curious how people solve this. In case there's some people who are confused, what am I asking you to do? I've defined this. I have written an equation which represents demand, and that's the quantity demanded equals 4 minus the price squared. I've defined quantity supply as quantity supplied equals 4p minus 1. Of course, this can only be true for p greater than 1/4. Then I ask, what is the equilibrium price and quantity of this model? And what does that mean? It means you need to solve for P and Q, but not in terms of each other, because here they're solved in terms of each other. They need to be solved in terms of only things that are exogenous to the model. And in this case, they can actually solve them for numbers. I have this point here about adding a third equation. Did anybody get this on their own? I gave you a quadratic equation here. So some of you be like, what the heck, what do I do here? It's quadratic, how do I solve it? You can either factor it or you can use the quadratic formula. But I'm kind of curious what you do and how you respond to this. maybe I should use. I'm going to explore some other options of using a whiteboard for people. I think I'm gonna use a whiteboard. Well, I only have 13 minutes left. Okay. Does anybody want to volunteer how they did this? Or like, what's the first thing you should do for this problem?
So I'm attempting it now, and I feel like kind of stuck here. I mean, I first put, you know, QD equal to QS to find
Good.
the market equilibrium.
Okay.
Here, let me put my camera on it. I don't know if you can see this. But yeah, like I'm kind of stuck here. So I put them equal to each other. I've been trying to like find the right signs as well, but it basically led me to 0 equals p squared plus 4p minus 5. And I've been trying to like factor that, but I don't think I did it right, to be honest.
Okay, so 4 minus p squared equals 4p minus 1. That's good. You added 1 to both sides. You then moved everything to the right side of the equation. But shouldn't that have been? Oh, okay. No, you didn't. You got 5 minus 4p minus p squared. I think that should be okay. And then you have p squared plus 4p minus 5. I think that should be okay too. I don't think you factored it properly.
No, I don't think I did.
You need to think. So you have a 5 in the ones place. That should be factored into a 1 and a 5, right?
Yeah.
What are the
yeah,
factors of the number 5? The only ones you can use are 1
5
and
and
5.
a positive 1. So it could be p plus 1 and then p minus 5. Or no, maybe
P
not.
plus 5 would work, and p
Okay.
minus 1.
P plus 5. Yeah, I see that.
So leave the p minus 1. That was right.
Oh, right.
But if you go p plus 5, that'll work.
Yeah. So that would be
Yes. So that's
p
good.
squared plus
Now you
5
have to think about
minus
what.
1p minus 5. Yeah, that works.
So if you solve that for p, you get 2 solutions. You get p equals 1 and p equals negative 5. Don't you?
That's correct.
And now you have to use your logical reasoning that this is an economics problem to say one of those is impossible.
And that would be the negative 5.
Yeah, you can't have negative prices. So just eliminate that. That means you've solved it. The solution is price is equal to 1. You can actually go back and calculate the quantity as well to say 4 times 1 minus 1 is 3. So Q, the quantity has to be equal to 3. Right?
Because you put the p equals 1 into the quantity.
Yeah, just go back and plug in p equals 1 into the original equation. Either one of them will get it to you.
So then I'll do it in QS.
Okay.
Equals 4 times 1 minus 1, and that would be quantity supplied equals 3.
Yes, very good. So could everyone see Kevin's? I made it bigger on my screen, but I'm wondering if everyone else could see Kevin's work there. So what did I do? I gave you an equation that wasn't just linear. And part of that, I wasn't just being tricky or trying to like get you. I'm trying to say is the linear models of demand and supply that you may have already seen are really just one specific case of a larger case, a larger set of possible supply curves and demand curves that include quadratic formulas or logarithmic or exponential or hyperbolic. As you get farther and further in economics, you're going to see some of these other types of demand curves and supply curves. You're going to see other types of utility functions, not the simple ones, but the more complicated ones. So what should we do? We should be able to solve no matter what math is given to you, using this concept of what does it mean to solve a model? You eliminate the variables. I don't know if Kevin even realized it, but what you were doing there was sort of eliminating. First thing you did was eliminate Q. Would you guys agree? I have this right here. Oops. Solve by eliminating variables. The variable that he eliminated in the very second line was Q. He was now starting writing the two equations together in a way where Q was gone and the only variable left was P. That's what you should do. And some of you are like, I already know that. That's obvious. But there's a way to think about, if I have two equations and two unknown variables, I want to eliminate it down so that there's one equation and one unknown variable. Then I can solve it. And in general, as long as the number of equations is equal to the number of unknown variables. Let's say I was a jerk and I gave you 4 equations and 4 unknown variables. That's a lot to work with. But this same concept of eliminating variables one by one until you get it down to one equation and one unknown, that's one method for solving a model, an economic model. So remember, the beginning of this lecture, I said, what does it mean to solve an economic model? And then I answered it. I said, it means to find an expression for each endogenous variable in terms of numbers, constants, parameters, etc., that are exogenous to the model. We did that for this example. Now, if my next question is, okay, how do you actually go about solving an economic model? I've just given you one way to do it, which you probably already knew. But my way is eliminate variables. You start off with 3 variables and 3 equations. Try to eliminate one of them so that you now have 2 equations and 2 variables. And then try to eliminate one of those until you have 1 equation and 1 variable. That's it. You've solved for that 1 variable. What about the other 2? Now you can plug that back in to the other 2 equations and solve for those as well. So this is a method. This is a method, I don't know how to describe it, the method of eliminating variables until you've gotten down to 1. And that's basically a solution. However, I don't want you to think you're done once you've solved for one of the variables in the model. Like if you had just said p equals 1, that's it, and you submitted that as your answer, that would be good. You get a lot of partial credit, but you wouldn't get full credit until you also told me what Q was equal to in this model. Okay, so that's an example of solving an economic model. Oops, what else do we got? Here's some principles. How much time do we have? 1:41. Okay, only 4 more minutes left. Maybe I'm going really slow. A system of equations can be solved only if the number of equations is at least as large as the number of unknowns. What I mean by that is, if I give you more unknown variables than there are equations, you're not going to be able to solve. You might be able to simplify the model. That's great. You could simplify the model, but you'll never solve it in the way that I've defined solution, because there'll always be more unknown variables. Okay, I will at some point teach you Cramer's rule, which is a shortcut, I would say, for solving linear equations. It only works for linear equations, but if you have like 3 linear equations and 3 unknown variables, Cramer's rule is a shortcut you can use to solve those a little faster. I don't know why. I think the person who taught this class before me taught students that, so I would too. The quadratic formula is pretty valuable. It's pretty useful. Kevin did not need to use it because he factored. He didn't quite factor correctly, but with some help, we got him to factor it correctly. Some quadratic equations cannot be factored, but you can always solve a quadratic equation using this formula. So if you have ax squared plus bx plus c equals 0, you can write down what the solution is for x. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's called the quadratic formula. I have a question. What happens if you have a quadratic equation, or a curve that is always above 0? What will this formula give you if it never equals 0? So you can imagine a quadratic function that never intersects with 0. What will happen to x in that case? This is like a high school algebra 2 question to see if you remember. You guys remember what happens back then? Let me draw it for you.
Is it going to be asymptotic?
No. Here's an example. Y equals x squared plus 1. Okay? Here's the y-axis. I'm sorry, this is so primitive. I want to be able to see myself now, so I can see what you're seeing. Why can't I see myself? I don't know. Stop share. Now I can see myself. Here you go. Here's an equation. Y equals x squared plus 1. It never intersects 0. But I just told you that the quadratic formula always works to see when does that curve equal 0. It tells you. The answer is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. I've memorized it because I use it so often. There's the quadratic formula. What is that going to tell me in a situation like this? It's kind of a trick question. When does this curve intersect this line? Of course, the answer is never. It never does. But the quadratic formula still works. Even in this weird case, it still works. What does it tell you? Nobody knows this, or you just don't want to answer? What is x going to equal to? If I had to solve x squared plus 1 equals 0, right? What would I get? I would get x squared equals negative 1, or x equals the square root of negative 1. What is that? What's the square root of negative 1?
That would be I.
It's I. It's called I. I is called the imaginary number because it's the square root of negative 1. The answer is actually plus or minus I, right? If x squared equals 1, I'm sorry, x squared equals negative 1, then either plus or minus I could be the answer. My point is that even in this case, the quadratic formula works. It will just give you an answer that involves imaginary numbers. They're not real numbers. A real number can be seen on the x-axis because this is like the real line from negative infinity to positive infinity. But imaginary numbers don't exist anywhere on that axis. Okay. That's just one tool to use. I sort of want to wrap this up. We'll finish talking about economic modeling next class. We will go on to the next topic or two, which is exponential log functions. I want to tell you a little bit more about algebraic geometry, but then in starting week 2, we'll do differentiation, and I'd still like to have our first quiz on February 4th, if that's okay. If there's any sort of Zoom related delays, we'll have to push that back too. But I think it'll be good to get us started to like, oh, what's the quiz going to be like in this format? I'd still like to have the first quiz on February 4th. So, and I'll try to get you a homework set that you could look at. That'll help you prepare for that first quiz too. But it's going to be what I would consider to be simple type questions about exponential functions and log functions, and kind of simple, how do you solve a model type questions. Okay. You guys have anything else you're concerned about or curious? It's kind of a small class this year. I think that could be good. You know, we could